Welcome everyone. We discussed about what is the alpha and the significance level alpha and the probability or the p value, right. So, and we understood its relationship and how to even calculate the p value, right, and then reject or not reject a hypothesis. Okay. So, today in this lecture we will be doing some problem solving, right. So, problem solving in terms of calculating the class interval, the range between which the values fall and the sample size calculation, and then we will proceed if possible, if time permits, in this lecture for even hypothesis testing, right. So, this case the first case we had done was this case is about when population standard deviation is unknown, right. The last case was where the population standard deviation was known to us, but now we are saying if the population standard deviation is unknown, then how do we proceed. Let us take an example. The mean annual income of 700 families living in a 4 square block section of a community. We take a simple random sample and find the results. So, what it is saying, there are 700 families in a locality and we have taken just 50 people out of it, or 50 sample. So, n is my 50, out of the 700 I have taken 50 people as my sample. The sample mean was x bar is equal to $11,800. The sample standard deviation, this is sample standard deviation, is 950. Here population, we have said the population standard deviation is unknown to us. Okay. The agency is asking us to calculate an interval estimate of the mean annual income, right, of all 700 families, so that it can be 90% confidence. So, what is the level of significance? The level of significance is 1 minus 90, so that is equal to 10%, okay, level of significance. Confident that the population mean falls within that interval. So, if I can know whether my population mean falls within that interval of upper limit and lower limit or not, that is what I need to check. Now, how do we go? Since the sample size is over 30, so it is it is following a normal distribution, right. The population standard deviation is unknown in this case, highlighted, okay. Therefore, we will use the sample standard deviation to estimate the population. Whenever, remember, whenever the sample population standard deviation is unknown to you, kindly use the sample standard deviation, or in a real life case you may calculate the sample standard deviation and use it for the population standard deviation. Now, let us go to this case. Since we have a finite population, there was one more thing in this case. Generally, whenever we do any study, we do not talk about the size of the population, or may not, we may or may not. When we are saying we may not, that is a case of infinite population, we do not know what is the population size. But in this case, the sample size is a finite sample size, right, and here it is only 700. So, in such a condition, what happens, the sigma x or the standard error which is to be calculated is calculated in a slightly different way. Instead of only measuring through the sigma by root over n, which we earlier used to do, we multiply it with another parameter, which is n minus n divided by n minus 1 the whole root over. Now, you see, suppose this n is now in this case 700, okay. Had this 700 instead of 700 been 70,000 or 7 lakh, right, you would see that there is hardly any difference that it makes on the standard error, right. But whenever the size of the population is small and the sample is a significant portion of the population, there it makes an effect, okay. So, now let us calculate the sigma x. So, the sigma x is equal to sigma, which is the value as s was 950, right. So, 950 divided by root over of n, which is 50, into the greater n, the population was 700 minus sample divided by 700 minus 1. So, this gives us a sample standard deviation or standard error of, sorry, not sample standard deviation, the standard error of $129.57. So, with 95% confidence level, what is our objective? To calculate the interval. So, with 95% confidence level, we would include 45% of the area on either side. That means, since it is two tailed, we do not know which side. So, it can go either this side or this side. So, we have divided this, oh sorry, this is not 95, sorry, this is a mistake, this is 90%, this is not 95, I think the question must have written 90%, this is 90%, it is, sorry, it is a typological error, right. So, 90% confidence level, 45% this side, right, 45% this side. Okay. So, 0.45 area is from the Z table or the Z table, in if you see it is 1.64 standard error, okay, away from the mean. Okay. So, the upper confidence level, that means, is equal to how much? Now, x bar sample mean plus Z sigma x, Z sigma the standard error. So, that is giving us a upper limit of this much, 12,012 sorry, and 11,587, right, almost I am missing the 50 the decimals. So, with 90% confidence we estimate that the average annual income of the 700 families lies between this much and this much. So, this helps us sometimes to test this helps to test even the hypothesis. Now, in our case, what was the sample mean? The sample mean was 11,800. So, does 11,800 lie between this? And obviously yes, right. So, this is telling us the class interval. Now, let us take another case. The last case was the sample population standard deviation was unknown to you, and even you had a finite population. Now, let us take this case when the interval estimates of the proportion from large samples. So, you are dealing with means, now we are dealing with proportions. Now, what is proportion in mean? As we all know that proportion are basically the ratios basically, right. So, a very large organization wants to estimate what proportion of the employees, right, prefer to provide their own retirement benefits in lieu of a company sponsored plan, right. There is a choice that the people can have their own retirement benefits or they can take the companies, okay, companies. A random sample, simple random sample of 75, n is equal to 75 was chosen and found that P, the proportion of success, right, was 0.4. 0.4 of them are interested in providing their own retirement plans. So, if P is equal to 0.4, so we know Q is equal to 1 minus P, so that is equal to 0.6. Okay. The management requests to use this sample to find an interval about which they can be 99% confident that it contains the true population proportion. Now, 99% is the confidence level that you need to check about, right. So, as it says, let us go to the solution. If P and Q for the population can be estimated by substituting the corresponding formula. So, that means it was earlier sigma x is equal to sigma upon root over of n, right, in case of means, but here what we are doing is sigma is equal to PQ, right, PQ. So, what we are taking is here this formula is changing to this one is coming up to this much, right. So, now the standard error of proportion, this is called the estimated standard error of proportion, this is equal to 0.4 into 0.6 divided by n, n was 75. So, this gives us 0.057. Now, what is he asking? At a 99% confidence level, that means 99% confidence level again has to be split up into two parts. So, 49.5, 49.5, right. So, this 49.5, this is 49.5 on either side, and 49.5 the Z value is 2.58 standard error, right, from the mean. So, let us see. So, how much is the upper confidence limit? You can also calculate on your at your own end. So, that is equal to proportion of success plus 2.58 into the sigma standard error of proportion. So, that is equal to 0.057, right. P was 0.4. So, let us replace this with it. So, the upper limit is coming to 0.547 and the lower limit is coming to 0.253. And if you see what is saying, thus with a sample of 75 employees with 99% confidence, we believe the proportion of the total population of employees who wish to establish their own retirement plan lies between these two values. So, if you go back, what was it saying? the if you look at this, right. So, the if you look at the problem, now from here he wanted to check at a 99% level whether the people want their own retirement plans or not. Now, yes, it is saying that the retirement plan, the people who wish to establish their own retirement plan lies between these two values, right. So, this is way of calculating the class interval when you are talking about proportions. Okay. Now, interval estimates using the T distribution. Earlier we were using the Z distribution, now we are talking about using a T distribution, because that means the sample size now what we are going to use or talk about is less than 30 and not greater than 30. Okay. Let us see. The plant manager wanted to estimate the coal needed for this year. A plant manager wants to estimate the coal, the amount of coal needed for the year. They took a sample by measuring coal usage for 10 weeks. So, n is equal to 10. So, we said whenever n is equal to less than 30, it is a case of a T distribution. Now, degree of freedom, what is this word degree of freedom? Why it is important? It is important because degree of freedom helps us to understand what are the number of free parameters available. That means what? Suppose if you want to understand it in a real life example, let us say I tell you that the average of 10 people, the weight, average weight of 10 people is equal to let us say 500 kg. The total weight, not total weight of 10 people is equal to 500 kg. I am saying I have given you the let us say the weights of 9 people, A, B, C, D, I am giving 9 people. Do I need to give you the 10th person's weight? It is not required, correct, because you know 500 minus the weight of the 9 people's weight. So, that will automatically tell me the 10th person's weight. So, that is what we say degree of freedom is actually since in research you need to be, the word is used as parsimonious, you need to be as parsimonious as possible. That means you should be using minimum resources to get your result, right. So, that is why if in this case n was 10 and degree of freedom will automatically be n minus 1, because the 10th one is not required to be given. So, that is what is the degree of freedom, right. Sample mean is this much tons, the sample standard deviation, here also the sample standard deviation is given to you is 700 tons. The plant manager wants an estimate, interval estimate of the mean consumption, and he wants to be 95% confident, right. So, 95% confidence, again it is split up, right. So, let us see, this problem requires the use of a T distribution because it is less than 30 as discussed. Okay. Estimating the population standard deviation with the sample standard deviation, thus sigma estimated sample, this is estimated one, as this sign always please remember, this hat is indicates estimated value, right. So, is equal to S is equal to 700 tons. Now, estimate the standard error of the mean of an infinite population using the formula what? Now, estimated standard error is equal to estimated sample standard deviation or estimated standard deviation, which is the sample standard deviation divided by root over of n. Now, what was the estimated standard deviation or the sample standard deviation 700 given by root over of n. So, n was 10. So, that gave us a standard error of 221.38 tons. Okay. From the T table, remember the T table and the Z table, there is only one difference. The Z table is less flatter, right, and the T distribution is more flatter in comparison to the Z. So, that this is the T, this is the Z. So, the only difference between T and Z is the flatness of the curve. Now, if you increase the sample size, the T starts growing up, right, till it reaches a point of the Z distribution. That is why, this is the reason why you do not see the Z distribution, in any software or anywhere, you do not see a Z test, you always see a T test, because the T test is naturally after sufficient sample size, it behaves like a normal distribution, right. So, let us come back to this case. The upper confidence limit is x bar sample mean, right, plus 2.262 this is the Z value, right, or the T value from the table into the standard error, right. So, even the formula remains the same, if you can see T or Z, the formula remains the same. So, this is finally becoming the upper confidence limit is equal to 11,901 ton, the lower limit is equal to 10,899. So, with 95% confidence, the manager will say that the mean weekly usage of coal lies between 10,899 and 11,901. So, this is very important. This is very important because from the management's point of view, they need to know ki they should lie between this value. If you go less than this, there is a chance that you might run short of coal. If you go above, it is unnecessarily a wastage, you are keeping too much of buffer or unnecessary inventory, which is also not good, it is a waste of money. Had you changed this value, let us say in this case from 95 to 99%, what would have happened? Then one thing would have happened is, as you can see from a practical point of view, if I am saying 99% confidence level instead of 95, that means I want to be more confident. When are you more confident? When you have more resources, correct. So, that means my Z value or the T value from the table value, this will not be 2.262 anymore, it will be much is higher than, for a 99% it is higher than the 95% value. So, when this is higher, automatically the absolute value also will become larger than what this one is, plus something, right, plus del x, let us say, and plus also del x, right. So, that is what it says. When you are increasing the 99 with the confidence level, automatically the interval size range changes, right. Therefore, now you see what has happened, as you have increased the confidence level, your alpha, the significance level was 1%, has become 1%. So, as you reduce the alpha, right, now the beta might also correspondingly change. If you go back, remember the last lecture. So, we said that alpha and beta are related. So, now the chance of having a beta is also changing with the alpha. So, this needs to be very clear. Okay. Determining the sample size in an estimation. Why this word estimation? First, let us need to understand. Estimation is, many a times you need to focus on a very close value or an estimated value which is close to the mean, very close, or a focused point, a point, we say sometimes it is a point estimate, right. So, this is the mean, let us say this is the mean, then we want it to be as close to the mean as possible, right. So, when you are talking how to determine the sample size, right. So, earlier also you have seen the formula was Z or T, whatever Z or T was equal to x bar minus mu upon standard error, correct, this was the formula. So, standard error was, we said Z is equal to x bar minus mu upon standard deviation by root over of n. So, that means I can just simply calculate n, the sample size, from here also if I know the Z value, right. So, that means what, Z into sigma by root over of n is equal to x minus mu, right. This implies root over of z into z sigma divided by x minus mu, x bar minus mu is equal to root over of n. So, if you just do it, x minus mu is nothing but the precision. So, z sigma, right, z square sigma square, right, divided by x minus mu. So, mu is your population, x bar is a sample. So, the difference. So, this difference is nothing but a precision. So, precision can be is noted as P, maybe, let us say P, or sometimes in books you will see it is as D. So, this is nothing but the difference between the population and the sample mean, right, into square, right, is equal to n, that is all. Okay. So, let us see this sample size for estimating a mean. A university is performing a survey, of the annual earning of last year's graduates from its business school. It knows from past experience that the standard deviation of the earnings of the entire population of these graduates is about 1500. So, the population size is known, right, it is a finite population, is about 1500. How large a sample size should the university take in order to estimate the mean annual earnings of last year's class within 500 at 95% confidence? So, what it says, let us go back. Standard deviation of the annual earnings of the entire population, which is 1000 people, of these graduates is about $1500, right. What should be the sample size the university to take to estimate the mean annual earnings of last year's class within 500 of this year's, right, at a 95% confidence level. So, how will you approach this problem? So, what you can do is you start thinking about it a bit and then we will proceed, right. Okay. First let us calculate this z, we need to calculate this z. Now, what is z? Now, z is equal to x minus mu divided by standard error, right. So, z sigma x in this case is equal to 500, just let us look if you go back, what is it saying? Z into sigma x. Now, x minus mu that means the sample minus the population. So, this is the precision, the exact, the difference. It said that in the question it said it should not be more than 500, right, it should be close to 5, just let us you see the annual earnings of last year's class within 500. So, we are saying this should be not more than 500, right. So, this is equal to x minus mu is equal to z sigma x. So, that means what? Z sigma x is equal to 500, okay. This is what coming, and z is 1.96 because it is at a 95% confidence level. So, what is my sigma x? Now, sigma x is equal to 500 divided by 1.96. So, that is equal to 255, okay. So, if this is 255, what is my standard deviation? The standard deviation was 1500, the population standard deviation. So, that means what? We are saying root over of n is equal to, you see, 1500 divided by 255. So, n is equal to this much, right, root over of n. So, that means this is equal to whatever the n is equal to finally this n is equal to finally if it is calculated 34.6 or 35, almost approximately 35. So, if you take 35 samples in this study, then you will get a result which is almost 500, within 500 of the class limit of the earnings of the last year's graduates, right, at this is at a 95% confidence level, right. So, I think this is clear, this is very simple. So, you just need to understand one concept in this, that this was you are talking about the closeness. So, x minus mu. So, that is what you need to understand, otherwise other things are simple, right. Now, this is another condition, the sample size for estimating a proportion. So, this was mean we talked about, now proportion. Let us take this case again. Suppose we wish to poll students at a large state university, right. We want to determine what proportion of them is in favor of a new grading system. So, though there is a old grading system and a new, students are always thinking that the old grading systems are generally, sometimes we think it is poor, the old things are also poor, not necessarily. Let us see this. We would like a sample size that will enable us to be 90% certain of estimating the true proportion of the population of 40,000 students, 40,000 students, that is in favor of this new system within plus and minus 0.02. Now, so here also let us see what to be done. In this case, the table z value for a 95 is 1.64 standard error from the mean, right. Now, z sigma p is equal to same thing if you go back. So, we said p as for example, the mean what it was, now x minus mu, right. So, in case of proportions what did we say, p minus p bar, right. So, p the p bar minus p is what we require. So, it says this p bar minus p is equal to 0.02, correct. I think that is what it is saying. Let us go back to the question. We would like a sample size that will enable us to be 90% certain of estimating the true proportion of the population of 40,000 students, that is in favor of the new system within plus and minus 0.02. So, this difference between these two, p bar and p, right, the success of ratio is need to be only 0.02. So, that means what it is saying, if this is then that means if you calculate, you find out that your sigma p standard of proportion is equal to 1.64, that was the z value, divided by 0.02. So, now that is equal to, if you go, sigma p is nothing but p q by n, we have already done that. So, n is equal to p into q divided by, so find n, we still need an estimate of the population parameter P and Q. Since it was not given to us, we could not, suppose it would have given us, then we would have said P suppose is let us say 0.4, in one case we had done. So, P was 0.4, Q was 0.6. So, this becomes 0.4 into 0.6 divided by this value, right. So, if we have strong population feelings about the actual proportion in favor of the new system, we can use that our best guess to calculate n. But if we have no idea what P is, suppose you have the idea of what is your rate of success or your accepted value of proportion, accepted ratio, accepted proportion, then it is okay. But if you do not have any idea, the best strategy is to guess at P in such a way that we choose it in a conservative manner. Now, what is this conservative manner? So, in this condition, if you do not know anything, take P is equal to 0.5 and Q is equal to 0.5. So, when you do not know anything, the probability of success, let us take it 50% and the probability of failure, let us take it 50%, right. So, then n becomes, in the last case, had it been given, as I said, 4 and 6 I had taken from the last one example which I had talked about proportions. Had it not been given, then I would have taken 0.5 into 0.5 and by this much. So, this gives me a sample size of 6. So, that means to be 90% confidence certain of estimating the true population true proportion within 0.02, right, we should pick a simple random sample of 1680 students to interview. If you take less than that, then you will not be able to find, right. So, this is what it is saying. So, I think what I will do is, instead of going to the next session lecture now, what I will do is I will discuss what we have done in this lecture. So, we understood the importance of p value also, right, and then we understood the relationship between p, alpha and other things, and then we helped it helped us to calculate the interval, the range, the interval of the range for any study for a condition where the mean you are testing for means or maybe testing for proportions, but you are also helping you in calculating not only the interval, but also the sample size by using the same formula that we have been using for z or t, which is z is equal to, we said, x minus mu upon standard error, right. So, standard error will slightly become different when you are calculating for proportions, right. So, when you are calculating for proportions, as we said, the standard deviation is nothing but root over of p q, right. So, ultimately the formula changes. So, now I think you are sure that what is this mean, what is this proportion, and how the formula or the class interval calculation changes and the sample size calculation changes in terms of a mean, in terms of a proportion. What happens when there is a finite population and when there is an infinite population, that also you have learnt. What happens when the probability of the p and q is not given to you? What do you do? What do you do when the population standard deviation is not given to you, and what do you use? You use the sample standard deviation in that case. So, these things need to be very clear for a researcher, because in real life, in practical, nobody is going to give you in a paper or something. So, this data you need to sometimes calculate, and therefore, some kind of deviation, some little variance is acceptable, but then you should have a clear idea, how do I measure, how do I calculate. These things we will later on also do it on the software, and I will show you how this is calculated, but for another 1 or 2 class we will get into this calculation on the paper, or let us say on the board, right. I hope this class was clear to you. The most important thing that I would say in this class was to understand the probability or the p value, and then how to calculate the interval, right. Thank you so much, have a nice day.